This presentation is entitled Spent Grains, Current Management Practices and Potential Value, submitted by Bryan Sadowski for CE 563 Industrial Water Quality. The major topics covered in this presentation include the characteristics of spent grain wastewater, some best practices for waste management and pollution prevention, some conventional and new technologies being used, and an outlook for the industry as a whole. Brewing beer has existed for most recorded human history and today generates more than $91.6 billion of annual revenue in the United States. Industrial brewing utilizes many unique processes, such include malting, milling, mashing, boiling, fermenting, and conditioning. There are four major contributors of waste from industrial brewing, excluding those generated during CIP. These wastes include spent grain, hot trub, residual yeast, and diatomaceous earth. This presentation will focus on the spent grains, which is generated in the mashing process. Mashing involves mill malt being converted from starches to fermentable sugars. The result is a sweet liquid called wort. The liquid wort leaves behind exhausted mill grains called spent grains. This waste makes up a majority of the overall waste and is high in organic content and contains various trace minerals. Here are some commonly observed moisture content and temperature ranges of the waste. Typically, spent grains consist of predominantly fibers, proteins, and various amino acids, vitamins, and minerals. The mixture is largely solid-based but can flow as a slurry and is often combined with other brewery waste streams. Spent grain contains several minerals such as calcium, phosphorus, and selenium. Much of the waste is organic matter of predominantly fibers such as cellulose, hemicellulose, and lignin. This waste is a perfect cocktail for the growth of microorganisms, especially with a higher moisture content. This waste can be, but is not commonly, further characterized by wastewater parameters including TOC, BOD, and TSS. This table shows some of the measured parameters of a combined wastewater stream from an industrial brewery in South Africa. However, they are very representative of waste characteristics of industrial breweries. Some best practices have been developed to try and manage the waste generated by brewing, such as operators of the lather ton should be trained to avoid overfilling during mashing, installing meters to ensure accurate additions to the process, and attempting a dry removal of sittable solids with a brush or rake before wasting machines. As previously discussed, the mixture is a breeding ground for microbial life, which also means microbial contamination is a distinct possibility. A common solution is a reduction of moisture through drying, which makes offsite disposal also cheaper, and other methods include chemical preservatives such as ammonium and acetic acid. The Clean Water Act gives power to local environmental management authorities to regulate industrial discharge. These regulations require spent grains to be pre-treated due to this classification as a pass-through and potentially an interference due to its high BOT as well as nitrate and orthophosphate concentration. The large concentration of nutrients such as nitrate and orthophosphates can cause algae bloom that can produce harmful toxins. The waste can also create aesthetically unpleasing and odorous surface water. Finally, excessive BOD concentrations can reduce DO in water and suffocate aquatic life. A common method for treating spent grains is separation of phases using a filter press and then dry to remove moisture. Mixed brewery wastewater is often treated with traditional physiochemical methods such as flocculation or flotation. These methods are effective at particle removal. However, further treatment is always needed to remove the dissolved organic matter. Aerobic reactors are supplied with air and generate soluble sludge, while anaerobic reactors are without air and generate biogas. Both types are used in brewery wastewater treatment, but the more commonly used is the combination systems. These systems are able to remove up to 98% of COD, as well as reduce sludge production. Currently, a large portion of dried spent grain is utilized as animal feed in industrial farming. Spent grain contains high concentrations of proteins and fibers that can be combined with inexpensive nitrogen sources to provide nutrition to livestock. The concentration of proteins and essential amino acids are observed to improve growth of livestock. Carbon nanotubes are a technology of interest in treating brewery wastewater due to their absorptive properties with organic pollutants and some nutrients. Microbial electrolysis can potentially be effective with treating spent grain wastewater and creates clean burning hydrogen gas. I'm going to be discussing this a little more in detail. Microbial electrolysis has the capability of treating COD in wastewater and produce hydrogen gas. An agnostic reactor containing an anode with bacteria that catalyzes organic matter in wastewater releases electrons and hydrogen ions to the cathode, where a second reaction generates the hydrogen gas. On-site, this process could be accomplished by adding spent grain wastewater to cycling processed water, which will dilute the concentration. The diluted stream could then be treated by the process, consume the waste organics, generate hydrogen gas for usable energy, and recycle treated processed water back to the beginning. By utilizing biological treatment, this waste can be disposed of while at the same time offset some energy requirements of the brewery in a clean burning way. Breweries are searching for innovation that will save energy as well as present their products as a more sustainable option. This is quickly becoming a popular and almost requirement of producers. Further research will focus on reducing waste and recycling as much energy and/or materials as possible. An example is Alaskan Brewing Company is now burning their spent grain in a biomass boiler. Breweries are incorporating environmental sustainability and energy efficiency into their business plans, and this trend is only expected to increase in the near future.